Hey guys, let's go ahead and get started with 8.1 Exponential Functions Introduction. Now we have an equation here, y equals a times b to the x. Now when I'm looking at this, there are the variables y, a, b, x. And let me tell you which ones I know I need to watch out for. The first one is I need to look for the variable x. That variable x needs to be in the exponent. Without a doubt, that variable has to be in the exponent. On this whole worksheet that you're working on today, that's the first thing you are going to look for. Now, that is going to be called just the exponent x, or there's going to be a t there, but today we're always going to see x, okay? The next thing that I want you to look for, let me fix that there. It's also referred to as time. So when we get to our word problems, look for the word exponent or look for the word time, okay? The next thing that's always going to be there is that variable y. Sometimes they'll write it as f of x, but all that means is what is the output? What is the future value? What's the answer? So the one that you're going to hear me say the most is going to be, what's the output value? Okay, what is that answer that we're looking for? Now, the other two variables, a and b, they are actually going to be numbers in the equation. The a is going to be our initial value, our y-intercept, or our starting value. What did we start with? The one that you're going to hear me use the most is going to be, what's the initial value? But again, they could use any of these, okay? Then the last one is b. But b is very important because b can tell us whether our function is going to be an exponential growth or an exponential decay. All right, so when we're looking at that, let me move this out of the way for a second. When we are looking at b, if b is bigger than 1, like 1.2 or 3 or 1.5, it's any number greater than 1, that is going to be considered an exponential growth. Something is growing if it's bigger than 1. Now, if b is a number that is between 0 and 1, so can't always say a fraction because sometimes a fraction could be greater than 1. But if b is between 0 and 1, like 1/2 or 0.25, then that's going to give us an exponential decay. Now, this b could be referred to as a lot of things. We could just say, hey, is it greater than 1? It's a growth. If it's between 0 and 1, it's a decay. It can be called the common ratio or the multiplier. Most times you're just going to hear me ask, hey, what's the b value? That's all I'm looking for. Okay, what's that b value? And it's referred to as the common ratio or a factor. It's got a lot of different names. But again, you're going to hear me say the b value, or is it a growth or a decay? So I have a bunch of examples listed here on number 1 through 18. So I'm going to go through probably about 7, 8 of them and kind of see if we can get into this pattern of what I'm looking for. Okay. Very first thing I'm going to look for, though, is I'm going to be looking to make sure that this exponent is the variable x. If it's not the variable x, then this is not an exponential function. And today, all we're looking for is exponential functions. All right? So I'm going to start with that. Let's just get that out of the way. When I look at number 1, does it have x in the exponent? Yes, that's exponential. Number 2, does it have x in the exponent? Yes, then that's exponential. Number 3, has x in the exponent? That's exponential. Number 4, does not have x in the exponent. So this one here is not exponential. That one is actually linear. Okay? So the x needs to be in the exponent. Right? If it's not in the exponent, you can just write down not exponential, cross off these other two because we cannot find the initial value or the common ratio if we're not looking at an exponential. right? So you can do that through this entire worksheet. Make sure that the variable in the exponent is x. That's number one. That has to be done, okay? All right, next thing. Once we see that the variable x is in the exponent, the next thing we're going to be looking for is what is the value of a? Well, a in this case is 9. Remember, that's also the y-intercept, so that's also 0, comma 9. What's the b value? Well, b is 1/4. Now, it's easier for me to see it as a decimal. Then I can easily tell if it's greater than 1 or between 0 and 1. And 1/4 is the same thing as 0.25 or as 25 hundredths. Now, because I can see it as a decimal, then I know that b is between 0 and 1. Now, since b is between 0 and 1, it's an exponential decay. Now, you can abbreviate this. You can write it all out, whichever you choose. Because I don't have a lot of room, I'm going to go ahead and abbreviate exponential decay. All right, now let's look at number 2. Now, on number 2, what is the a value? The a value is 5. This is also the y-intercept, so it's 0, comma 5. What is our b value? B is 3. Not a fraction, so I don't have to worry about that. Now, when I look at 3 for the b value, b is greater than 1. So this one here is exponential growth. Okay? All right, let's look at number 3. Number 3, the a value is 25, or it can be written as an ordered pair for the y-intercept, 0, 25. The b value, the multiplier, is 2.5. Now, 2.5 is a decimal, but this time that is still greater than 1. So then that means it is exponential growth. Okay? All right, now let's look at number 5. Number 5, on this one, I can see that there's a b value because it's right beneath that exponent. So the b value is 2.7. But what's the a value? Remember that there's always an understood 1 if they don't put an a value. So our a value is 1. Now looking at this, remember this is 0, comma 1. Our b value is 2.7. So b is greater than 1. So this is exponential growth. Anytime it's bigger than 1, that means it's growing at more than 100%. Okay? Number 6, the a value is negative 7, or 0, negative 7. Our b value is 5 over 2, or we can write that as 2.5. 2.5 is greater than 1, so this is exponential growth. Okay? All right, let's go down and look at number 12. Now, if you notice here on number 12, there's no parentheses around that 5, but that 5 is just beneath that x. Okay? So that is our base. That is our b value. And again, our a value is 1. So that's 0, comma 1. Then this one here, b is greater than 1. 5 is greater than 1. So then this is exponential growth. All right, let's go do one more of these and then move on to some tables. Number 18. On number 18, our B value is 0.7. Our A value is 3, or it's the y-intercept, 0, 3. 0.7. B is between 0 and 1. 0.7 is bigger than 0 but smaller than 1. So this one here is exponential decay. All right, so then let's go on to some tables. Now on these tables, if we have an exponential function, we can look first. We need to make sure that the x values are just increasing by the same number. So let me talk about that for a second. Let's talk about this. From -1 to 0, that's going up by 1. From 0 to 1 is going up by 1. From 1 to 2 is going up by 1. From 2 to 3 is going up by 1. Okay, so the input values have to be going up by the same amount each time. As long as they're doing that, then we can jump to find the common ratio, the B value, right? So to find the B value, we have to find out what are they multiplying the y's by each time to get the next y value. So if I'm looking for B, how are they multiplying 50 to get 150? How are they multiplying 150 to get 450? How are they multiplying 450 to get 1,350? And so on. Now, whatever they're multiplying by has to always be the same. That's how we find our common ratio B. Okay? So how can I find that if I'm not sure what they're multiplying by? Well, we can take any y value and divide it by the previous y value. So if I wanted to take 150 and divide it by 50, that gives me 3. Well, if I wanted to take 450 and divide that by 150, that also gives me 3. If I wanted to do 1,350 divided by the previous one is 450. That also gives me 3. So every time we are doing that, multiplying by 3. So the multiplier or the common ratio is 3. So B is 3. Now to find the A value, that's the y-intercept. So our y-intercept is 0, 150. Now we're going to use that A value and that B value to write our exponential equation. So we have y equals 150 times 3 to the power of x. Now remember, the variable x has to be in the exponent. Look at the B value. Is 3 greater than 1 or is 3 between 0 and 1? What's greater than 1? That's exponential growth. Okay? All right, so let's go to example C. Now, example C, first look at your x values. Make sure that they're going up by the same amount, 0 to 1, 1 to 2, 2 to 3, 3 to 4. That's good. Now, how do they multiply 32 to get 16? How do they multiply 16 to get 8? Remember, what we're looking for is that common ratio so we can find the base. What are they multiplying by each time? Now, if you notice, the numbers here are getting smaller. So since the numbers are getting smaller, that should be a hint to us that this is going to be an exponential decay. That should also be a hint that these numbers here are actually getting further away from 0. Okay. Getting closer to 0 as they go on. So, but as I'm looking at these, I'm like, wait a minute, if it's a decay, then that B value has to be between 0 and 1. So 16 divided by 32, if I wanted to do it that way, would be 0.5. 8 divided by 16 is 0.5. So what are they multiplying by each time? 0.5. Now, that's also the same thing as 1/2, but unless the answers give us fractions, we're okay to use decimals. So our B value is 0.5. To find our A value, look for our y-intercept, 0.32. So A is 32. Now, when we write the equation, we can write y equals. Keep in mind, we can also write f of x equals. Okay? Then we have our A value is 32. Our common ratio is 0.5 to the power of x. Now, what it's not is that it's not this. That is wrong. Okay? This x has to be in the exponent. It cannot be written next to the 0.5 like it's being multiplied together. They have two different meanings. Okay? All right, let me go ahead and erase that mistake. All right, so this one here, B is 0.5, okay, or 5/10. So that is actually between 0.0 and 1. So that is an exponential decay. All right, let's go on to our last example together. Example E. Now, the initial value on this one, our A value, is 0.3, so 3/10. Now, to find the B value, we've got to see what is it multiplying by each time. What's our B value? Okay, look at those numbers. Are they getting bigger or are they getting smaller? Well, they're getting bigger, so that's a good hint that that's going to be an exponential growth, but let's make sure. 0.3 times 3 would make 0.9. 0.9 times 3 makes 2.7. And every time we're just multiplying by 3. So what's our multiplier? What's our common ratio? 3. So we know that this one's a growth. So y equals 3/10 times 3 to the power of x. All right. All right, so the last thing I want to tell you is there's a video here that helps explain exponential graphs that I've suggested there for you. And then there's an Khan Academy exponential growth versus decay that's already there that you can work on this evening. Remember, that's not due till Sunday at 11:59 p.m. Now, today in class, you should be completing the rest of this worksheet that says Monday. So you should be doing 1 through 19 and D, E, and F. All right? See you soon.